Hi. Now let us spend some time on differentiating the types of the hypothesis testings as far as the scope of the Learning Plan 4. Within Learning Plan 4, we study one sample test and two sample tests. The types we study z-tests and t-tests. Uh, uh, when we use one sample test, when we use one sample hypothesis test when we hypothesize about a single population parameter, and alternatively when we have samples from two different populations and we want to hypothesize whether the parameters of those two populations are equal, we use two sample tests. And again, we can have either z-test or t-test. And depending on the information we obtain from the mother population, that's what defines whether we will be using z-test or t-test. I have presented on the board the formulas for calculating test statistics for t-test, one sample and two sample. So, for example, the null hypothesis for one sample t-test would be whether the population would be equal to hypothesized parameter mu0, and the alternative hypothesis whether the population under the test wouldn't be equal to the hypothesized parameter mu0. In this case, population parameter is the mean. The test statistics T0 is distributed as a T distribution, and we calculate sample average, we calculate sample standard deviation, we utilize hypothesized parameter mu0 and number of samples pulled into the test, and calculate the test statistics. And then we compare to the critical values of the T distribution, which we obtain from the table. Of course, the software allows us to automate this process, and we don't do these calculations manually. We do it manually just for the sake of learning. And also software will provide a value, a p-value, which, looking at it, we will understand whether null hypothesis is rejected or not. And usually if p-value is less than the level of significance, we reject null hypothesis. If p-value is greater than level of significance, we do not have enough evidence to reject null hypothesis. Similarly, when we have a hypothesis about parameters of two populations, in this case is population means, and we use two sample t-test. Again, the null hypothesis is whether the difference of the mean of the population 1 and population 2 equal delta, and in this case delta could be 0 or some value, and most of the time we utilize 0, and which will turn the null hypothesis whether population mean 1 mean is equal population 2 mean, and alternatively whether two population means are not equal. So this formula, which utilizes the difference between the averages of these two samples pulled into the test and and also the delta over pooled standard deviation of those two samples. It's pooled standard deviation is weighted average of the two standard deviations of two samples over and also multiplied by the formula by the square root where the number of samples pulled for the test from each group are presented. So we reject null hypothesis if the calculated test statistic falls outside of the critical value of the t-distribution. And again, software are utilized widely, and hardly anyone calculates for practical reasons the test statistic and determines whether hypothesis 1 is rejected or not, 0 is rejected or not by hand. So the p-value is looked at and which helps to determine whether what is our decision about the hypothesis. Okay, and I mentioned that these days everything is done by software, and as one of the objectives of this course I would like to assign the seminar assignment using software, and the Excel is widely available. So let us continue our seminar looking at the example how to conduct a t-test using Excel. Okay, see you then.